My name is Bryce Harrington. I've been working at Samsung for about 4 months now, and I've been looking at Cairo and its performance. I'll be talking here today about the spans compositor a little bit, and testing in general for Cairo. I assume everybody knows what Cairo is, but just in case you don't, it's a 2D drawing library that a key feature that it advertises is that it targets both display on the screen and print. So the idea is that if you write code that draws something to the screen, it should be pretty straightforward to make it write out to a PNG file, or a PNG or a PDF or SVG file, and it should look exactly the same. Architecturally, Cairo is structured with a back-end architecture, and the back-ends allow you to plug in different algorithms and technology for both for different output formats and for accelerating display by using different systems like GL. So here's a picture. I don't know how well you can see that. I sold this off of a really cool tutorial that was done for Inkscape to describe how Cairo works. And so basically, this shows drawing two shapes. You have a star with a gradient, and you have a rounded rectangle, and you want to merge them together into a scene. And that's called compositing. And you take multiple graphical elements and squish them all together. And you can see there's different things you can do to the image to get it to compose. You can do translation, so you can rotate things or move them around. You can put on clipping, you can set paths and so forth. You can also use raster images as your source rather than vector drawings. So that's compositing. Now, where is Cairo used? I did a search on Ubuntu for things that depend on Cairo, and there were hundreds and hundreds of packages. Of those, I've listed just a few. It's included in GDK, and so because of that, it's used all over the place. Window managers like GNOME and FCE that use GDK obviously use it quite a bit. Even applications like GNU Plot, GNU Cache, basically anything that starts with a G uses Cairo, it seems like. Mozilla also includes Cairo, a snapshot of Cairo in its code base. They've been looking at other rendering engines, but I believe they still use Cairo in current releases. I mentioned events because they use the PDF backend pretty heavily, and so there's been a lot of bugs that have come because of that, viewing random PDFs. Scribus is actually a Qt application, so I think they must really want Cairo in order to, if they're depending on it. I don't know exactly what they're using it for, probably for canvas rendering or something or other. Inkscape is a project that's kind of near and dear to my heart because that's one that I helped found years ago, and it originally used it used its own rendering engine that it got from a project called Sodipodi. That was replaced over the years with one called the New Renderer, and that's what Inkscape has mostly been using up till now. Since their last release, the 0.48, they've been working on ripping out that rendering engine and putting Cairo in. And that's gone really well. They've been able to eliminate a lot of long-standing performance problems and regression issues and stability problems. And it was really important to them that in doing that transition that it not cause any regressions for users. And by and large, that's been pretty successful. There have been a few regressions, but they've been able to work with the Cairo project to get those solved. Now, one of the reasons I mention this is because a lot of attention right now goes into 3D optimization, 3D technology, OpenGL, and so forth. And so you might think, well, something like Cairo, it's just 2D. What does it matter? Well, 3D is great, and if you're doing gaming, if you're having a composite desktop, so on and so forth, it's really important for those things. But for a lot of us, especially as developers, it's applications like these that we care about. So things like Cairo, I think, are really important to keep in mind and to look at and do performance work on because of that, because it directly helps a lot of us that use these things day to day. Now, we mentioned the Cairo backends, and so here's just a quick list. I don't think this is a comprehensive list, but this is some of the major backends in there now. PostScript and PDF are kind of related to each other. SVG is for vector graphics. Now, I just mentioned that GL doesn't really matter because we all use 2D. Well, actually, for Cairo, they have a backend that they've been working on for years for implementing it on top of cairo-gl. The idea is basically that the hardware that we have today that has GPUs that are optimized for 3D operations. So the hardware manufacturers are targeting game consumers, and so 3D performance is very important. So the idea is, why not take advantage of that for 2D operations, because 2D is just a subset of 3D, right? So it should be great. And so a lot of work's been, I think this started, 4 or 5 years ago, maybe longer, to try to implement a GL-based backend for Cairo. Now, as of today, this isn't available for many Linux users, and the reason is that, at least on Ubuntu, the GL backend is not enabled in Cairo. The problem is that we found that when you did that, we did actually turn it on in Ubuntu, and we found that NVIDIA users were getting huge memory consumption problems. Every time they launched an application, their memory use went way up. And in talking with NVIDIA, the problem is that their libgl has a bug in it that, when it gets linked into the program, uses a lot more memory. And there has been some work on resolving this. NVIDIA posted a patch to try to help. But as of now, I believe this issue still exists for people. So I think this is a really important thing to get solved in order for us to see cairo-gl. Yes?
Mesa has similar problems.
Mm-hmm. Does it?
One context will cost you at least 16 meg of RAM with one context.
Okay.
At least, or I measured maybe it's 20 or 30, but there's 16 meg just for context plus extras. So it's not just the NVIDIA, everyone has it for GL.
Right. So one idea that was floated around in this bug report that I've listed there is to make the GL functionality dynamically linked to applications. Because a lot of times the applications that were getting launched weren't using 3D at all, and may not have even really been using Cairo, they were just linked against it. So there's a lot of ideas in that bug about how to work around this. In addition to, when I say cairo-gl, this is actually kind of there's a set of different GL technologies that are being used. And the cairo-gl one is the one that's important for the desktop. But some of these other ones are more appropriate for embedded devices. And we don't have this problem, or the problem is a little bit different on embedded. And in many cases, you don't have 2D acceleration. So you really do want to use the cairo-gl if you're going to use Cairo on these platforms. So I mentioned compositing earlier. Cairo actually has several different compositors included in it. I'll talk about these in more detail. But one thing that I found is that you can control which one is being used in Cairo at the application level through this environment variable. And you can set whichever one that you want. Now, what are these four compositors? So, I think, yeah, I should mention Cairo, when I first heard about this, I thought, okay, there's 4 different compositors. Which one's the best one to use? Which, what do they all do, and when do you want to use them? Well, actually, I found out that Cairo has logic in it to select which one to use on a per operation basis. So you don't even need to think about it as a application developer or as a user. By default, it tries to use the MSAA compositor, which basically tries to pass off things directly to the GPU. So if you have shapes defined in your scene, it tries to render those as OpenGL primitives. The spans compositor is a little bit older. I'll talk about this in a little bit more detail on the next slide, but basically it takes shapes and it tries to break them up into lines and then pass those lines to the GPU for rendering. Mask, I don't really have I never really got a really good grasp on what exactly it does, but as I understand, it's a kind of in between spans and traps as far as performance goes. So it's a fallback for things that the spans compositor isn't able to handle. In my testing, I found that mask always just crashed. So traps was the original compositor, and it's basically splits the scene up into trapezoids and then renders those. Currently for cairo-gl, they only use that for text rendering. And then finally, if all else fails, it goes back to just plain old software rendering, which sounds bad, but actually, or maybe it is bad, but it performs pretty well. And so in a lot of cases where Cairo is finding that it has to fall back to the image backend, it just falls back to that for everything, for the scene. So this is a picture of kind of what spans does. So you have a shape and you want to render it to the screen. So it looks for areas that, series of pixels that are identical. And so rather than send each pixel to the GPU, it tries to send a line. And then an obvious optimization was, why not expand that into regular polygons? And so that's essentially how the spans compositor works. Now, I want to talk a little bit about how testing is done in Cairo. There's 3 or 4 different types of testing that you can think about that are implemented in Cairo, or at least 3 that are implemented in Cairo. The first is functional tests. So that's basically you're drawing a shape or a small primitive, and you want to make sure that it draws correctly. Micro benchmarks are you have a specific functionality and you run it in a loop and see how it performs. And macro benchmarks look at a more of a high level, what are applications actually doing? And then finally, I want to mention manually run benchmarks, just because it's been my experience with Cairo that a lot of the testing that actually gets done seems to be driven a lot by actual real world benchmarks that are being run on the hardware. So first, let's talk about functional tests. Cairo has a huge number of tests, and they take quite a while to run. So one of the first things that you learn to do is how to narrow down the set that you're running. I think it takes most of the day to run through them all, at least on my computer. So this shows running running the gradient alpha test, which was one that was just relatively short, with several different targets. Targets in Cairo terminology is basically, they mean backends, but targets can also be different variations on the backend. So like, for example, this includes 4 options for testing specific compositors within the GL backend. And you can see here that the mask test crashed. It always crashed for me, I don't know why. And Cairo also makes a really nice web printout that shows all the details. You can't really see it here, but it creates a visual diff. So you see two purple squares and another square in between. The first one is what actually got rendered. The third one is what it should have looked like, and the middle one is the difference between the two. And so using that, you can kind of get an idea of how things were failing. One thing that we found in doing this, though, that often the rendering is either hardware specific, or there have been changes in the code that haven't been updated with the truth image. So it's not entirely reliable. And right now the Cairo test suite shows maybe a third of the tests failing, and I think that's probably not accurate. So we're going through and trying to update test cases to correct that. So now moving on to micro benchmarks. I should say that functional tests are interesting, but as far as comparing spans with other compositors, it didn't really show that much difference. They pretty much all render the same. Micro benchmarks were much more interesting. So again, you can run make perf, and that'll run all of the benchmarks, and this takes about 2.5 days. So the next set of code there is how to narrow down exactly which tests you want to run. And so here we pass it as an environment variable. And we could specify that it's similar as before, test traps, test spans. And I picked wave as the test case again, just because it's really short. Many of the test cases have a lot of sub cases, and so you get a lot more data. So you can see here on let me see if I can get this working. There, yeah, here's the numbers that we care about. You can also run multiple iterations. I just ran it once, and now you might get numbers that are a little bit more accurate if you run it multiple times. But you can see that the traps and spans performed worse than if we were just using the software renderer. So that's no good. But then with the full GL, and I think that this is running with the MSAA, and so there we do actually see some benefit. Some of the other test cases are a little bit more extreme. I also did another set of tests on Wayland, or under Wayland, just to see what the difference would be. And this is actually on a different hardware, so I don't know if that affects the numbers. But you can see they're a little bit worse or considerably worse than under X. And so that's something that would be worth looking at in more detail. Now I mentioned that there's a lot of tests. There's actually close to 1,200 tests that can be run for performance. And so to compare them, running under spans versus traps, the older compositor, I basically listed the percent improvement of spans versus traps. And you can see here, first of all, the spans pretty much wins. In most cases, it's considerably better. The second thing you notice is that, well, why isn't it always better? What's with the ones that traps does better? And the third thing is there's one that's going off the deep end there. It's actually minus 400%. I haven't looked at all these test cases in detail, but I looked at a few. And the way that the test cases are structured is you'll often have the default baseline case, and then several that are exploring different options, tuning knobs, different things. And at least for the ones that I looked at, that's what the situation was, that they were playing with things that were not what users would actually use, not what you would actually use as a developer. Even still, those would be worth looking into in more detail. I ran it just in case it was a hardware issue. I ran it on 2 different machines, once with Intel and once with AMD, and you can see that results are pretty much the same. And in case anybody wants to look into it in more detail, this is a list of the specific tests that were doing really bad with spans. I should also mention that this was, in some cases, the issue may not be visible to users because MSA-A, the main compositor, may do those operations a lot better. And so it may be hiding those performance issues. All right, now the micro benchmarks are interesting in that they show you specific operations and how they're performing. But that doesn't always translate into real world performance because you're not, if you're rendering a scene, you're doing a lot more than just drawing a line over and over and over again. So macro benchmarks try to, or what micro benchmarks do or macro benchmarks, they actually take a trace of the application. So you start up the tracing tool and then run your application. You do whatever operations that you're going to do with it. And then you can replay those traces later. And you don't even have to have the application installed or its dependencies. So that's really handy. Cairo has collected a whole bunch of traces that are in the Git URL that I posted there. And it's huge. Once you unpack it, it's like 4 or 5 gigabytes. So, and it takes a lot. I mean, I have no idea how long that takes to run because I haven't run the entire thing. But individual test cases, you can unpack it and you can use these environment variables to narrow down which ones you want to run. So one thing that I did was to look at what the big function calls were in some of these traces. And you could do this by using the perf, the Linux perf tool. So using that, we'll record to a perf.data file, and then with that data file, you can do a whole bunch of different things to analyze the code. One thing is you can make these pretty charts. And this actually isn't Cairo. All the charts that I made of Cairo were really ugly and weren't really that useful. So this is one of just starting Inkscape and then closing it. And then this shows what functions were called the most and what percentage and so forth. And so you could figure out where your performance issues are with that. What I found to be actually useful for Cairo was just the perf report command, which just did a raw listing of all the commands. So for that fishbowl test case, I looked at which functions would be called the most. And the one at the top, cairo-tor scan converter generate, is obviously the biggest one. And I looked through there and it looked really tight to me. There wasn't anything obvious for optimizing there. It was very low level and it looked like people had already done a lot of work on it. But looking a bit further, I found 3 calls. And you can see here, some of the calls are in the script interpreter, which is part of the test framework. So you ignore those. And there's some that are in the kernel or libc, and so not much we can do about those. So the 3 remaining calls are called in this order. cairo-gl bounded spans, it calls the GL composite emits solid span in a loop, and that calls this last call in a loop. And so looking through this last call, one thing I noticed was that it was flushing the VBO buffer quite a bit. And I thought, what's a VBO buffer? So looking a little bit further, the VBO, or vertex buffer objects, is something in the hardware that lets you store information about your scene, the XY positions and vectors, colors, and so forth. And then you upload a program that will operate on that data. And so you do all your operations there in the GPU. And so that should be a lot faster. So I tinker around with that. What happens if we increase the size of that buffer? And I found that, sure enough, if you increase it up to about 1 megabyte, the performance is quite a bit better. And I found this both on Intel and AMD, and it's basically the same curve. I don't know if it would be the same curve on every hardware, because I would expect that older or newer GPUs may have different amounts of memory, so it could be different. Also, I've heard that larger VBO sizes cause problems on embedded platforms. And so because of that, it was set smaller than it had originally been developed to. So the default is 16K, which is a little bit on the small side for the desktop. Now, so the next thing I wondered is, okay, well, if we increase the VBO size, does that make actual performance improvements for anything else? So I did the same process with some of the other traces, and unfortunately I found that no, none of them were affected by that. So I don't know if this, while this is great for if you want to draw a lot of fish, I don't know if this translates into performance benefits that you'd actually see on the desktop. So it's still a work in progress, and if you want to check it out, I have it online. So just for interest's sake, these are the top function calls for some of the other benchmarks, macro benchmarks. And none of them have that same set of 3 functions. And you can also see that all of them have that cairo-tor, or almost all of them have that cairo-tor scan converter generate code in there. So while I didn't see any performance work to do there, maybe somebody else does, because it looks like that would have a big benefit. So, how to generate new traces. The traces that Cairo includes right now were done, I think, about 3 or 4 years ago. There's a whole bunch that are against Firefox, and then ones against other applications. And I think that it would probably be worth regenerating them because things change. But it would also be interesting to collect data against other applications too. And so one of some future work that I want to do is to collect traces for Inkscape. Right now, Inkscape does not use the cairo-gl, so you need to patch it to use cairo-gl, but that wouldn't be a big deal. And then do some analysis to see if it would actually improve applications like Inkscape. Another thing I'm going to be looking at is the Skia 2D compositor, or 2D drawing library, and seeing how that compares with Cairo. I think it would be really cool to see other applications besides these with traces, and see how what we can do to make them better. So, any questions?
When you talked about Intel, did you take a look at the specific graphics cards and drivers that were testing?
That one was,
915?
no, that was an HD 3000, I think. I'd have to double check. Mm-hmm.
With the VBOs, did you try an NVIDIA driver with those ones?
I did run some of these tests on NVIDIA.
Okay.
That one I don't think I did.
Okay, because there's some problems with the VBOs on NVIDIA, where basically I had to, Ennis was using VBOs. We had VBO code and I removed it, I disabled it. I went back to GL draw arrays, but of course on NVIDIA, whenever you map the buffer, the NVIDIA driver will sit and spin, consuming 100% CPU, waiting and syncing on the GPU. So if you're doing benchmarks, you don't notice because you're spinning anyway. But in regular execution, you'll find you'll just sit and pause and wait on the GPU, but in the process, your CPU will go through the roof. So you actually are probably better off not using VBOs and just doing your own buffers and GL draw arrays. You might want to have a look at it.
Thanks.
And it's really no performance difference on that I could measure on either NVIDIA, Intel, and actually same with GLES implementation. So actual embedded drivers.
Cool. Any other questions?
One question.
You
mentioned you have to do the optimization about the video, the vertex, the buffer of the object. So my question is that if this automation is depend on the specified hardware, just like if you optimize it in integer hardware, so if you port it to the NVIDIA's device, maybe the optimization is decreased or decreased. How to show it from your platform?
Yeah. So the question is if the VBO size is dependent on the hardware, how can you set that in the code to optimize it? And you know, the simple thing would be to just force it to 1024 or whatever, but that might break some other hardware. So the question is, okay, how can you make that a hardware configurable thing? And that's a good question. That's one of the reasons I haven't pushed this. Yeah.
You can just query the driver strings, because the driver strings will tell you what hardware you're on. So the vendor or driver renderer version from GL will tell you, and you can just configure based on that.
Yeah. So that means if we find that if we could do something optimization across the platform, we could maybe optimize and set up this in the OpenGL.
Well, one thing.
Parameters in OpenGL to make this cross platform.
Yeah. So one thing that I thought is if it literally is just an issue with embedded, why not just make it a compile time thing? Because if you're compiling it, you know what platform you're targeting, and for those particular cases, for the embedded cases, you can just set it to 16 or whatever. Another thing is if it is tied to how much memory the GPU has, could we query how much memory is available and then set it to that? Because then we wouldn't need a lookup table, we would need to update it with new graphic card names and so forth. So that's a good question, and I don't know the perfect answer to that, but yeah, that's something that we could look at. And again, I think that I would want to make sure this actually matters to applications and have some more data than this to show that it's worth tinkering with it. Any other questions? Yes.
So you're trusting Will's snapshot. It's not like code grind where you the real Will stack and everything going on. So did you compare out the two methods to be sure that they give you the same information at the end?
For the Cairo trace.
Well, for the tracing system, like.
Right. So the question, if I understand correctly, is when you collect the trace, can you rerun it to make sure that you have the same things being traced out? Yeah, it actually writes to a text file that actually lists the operations, and you can read through them. And depending on how you're generating the test case, like for example, the case where I just launched Inkscape and then closed it, I don't know that I would get exactly the same call sequence because I'm involved in the process. It may tweak the timings a little bit, but so I might not get exactly the same letter by letter output, but yeah, you could do that to analyze and make sure that you're getting the same thing. All right, any other questions? All right, well, thank you.